Hello, welcome. In this short video, let us look at a numerical method for finding the energy of a signal. So for example, given a signal x of t, we want to find the energy of the signal using numerical integration and of course using Matlab. So to start with, consider a signal x of t equal to e power minus t cos of 2 pi t u of t. So that is a signal with value e power minus t cos of 2 pi t into u of t. That is, it is only valid for positive values of time. So now we want to compute the energy of the signal. In a previous video, we have learned how to use the Matlab plot. That is, for example, we can plot the values of the signal or plot the signal in the Matlab and intuitively understand whether the signal is finite energy or not. So this cell basically represents that idea. That is, given a signal x of t equal to e power minus t cos of 2 pi t and only for positive values of time, we can look at the signal and its absolute value and get an intuitive understanding of its nature. That is, so the signal is given by e power minus t log cos of 2 pi t. That is, it is like a decaying sinusoidal signal. Now by looking at the absolute value of this signal, we can clearly see that the value of the signal is decaying with time. In other words, it will be a finite energy signal. But to actually objectively quantify the finite energy of this signal, we can use the numerical methods. For example, look at the third cell. That is, we create a vector, time vector with values from 0 to 10 with a sampling interval of 0.001, and then we define the function in terms of this time vector and compute its absolute value and square the result. That is, we have exponential of minus t cos of 2 pi t, and then we take absolute value and take the square value. That is, we are using the formula for energy. That is integral minus infinity to plus infinity x of t modulus x of t square dt, and then we are using a trapezoidal integration method for finding this an approximate value of this integral, or in other words, a numerical way of finding this integral. So that means we can calculate the integral using numerical means. Unfortunately, for this signal, we also have a closed form solution, so we can verify the result by using symbolic Matlab, and we can compute the energy of the signal by directly finding this integral using the function int. So let us look at these two results. So for example, by using the numerical methods, we have energy is equal to 0.2562, and then by using the theoretical method, that is a symbolic Matlab approach, we also find that A is actually equal to 0.2562, which is exactly same. So that means indeed the signal is of finite energy. So fortunately for this signal, we can calculate both the numerical, we can calculate the energy value by using both the numerical method and also the theoretical method. Now consider another signal x of t equal to e power minus t cos of logarithm of 2 pi t u of t. So in this case, in this case, we cannot calculate the energy by using theoretical means because this integration. So for this signal, it is not possible to find the energy by using the theoretical formula. We have to use numerical methods. Let us verify this proposition. Again, as the first component, we construct the vector and look at the signal and its absolute value to get an intuitive understanding of the nature of the signal. So that is the structure of e power minus t cos of log of 2 pi t. So basically, again, this is a signal that decays with time, and we can compute the energy both by using the numerical means and also the theoretical value. But unfortunately, the theoretical value cannot give a closed form solution, or it does not have a closed form solution. So when you look at the results, you can clearly see that A, that is the theoretical formula, clearly says that the integral could not be found. That means the integral for energy, that is integration minus infinity to plus infinity, square of the absolute value of x of t, where x of t is exponential of minus 2t into cos of log of 2 pi t. So again, by we can clearly see that the integration, the theoretical integration, does not give a closed form solution, because this integral, that is integration integration from minus infinity to plus infinity, square of the absolute value of the signal, that is where x of t is e power minus t cos of log of 2 pi t. So in this case, this signal does, you cannot compute the energy using theoretical means, but by using the numerical means we can actually compute the energy by using the trapezoidal integration. So the value is found to be 0.2208, which is obviously finite. So therefore the signal e power minus t cos of log of 2 pi t is indeed a finite energy signal. We have found this one by using both the numerical method, and also we can intuitively understand from the graph. So to summarize, given a signal x of t, we can find whether it is finite energy or not by using a numerical method. Basically we can compute the energy by using numerical integration. So for example, when we have a signal x of t which has a structure like e power minus t cos of 2 pi t u of t, we can actually theoretically calculate its energy and also use the numerical methods to find the energy. So that is what we see in the Matlab code. The first cell basically illustrates how to plot the signal and its absolute value, so that we can have an understanding of the nature of the signal. And the second part uses basically the symbolic toolbox and tries to find the value of the energy using the function int, that is basically trying to use the closed form solution. Now the third component basically shows the numerical approach for finding the energy. So that means we are using the trapezoidal integration method for finding the energy. So in this, for the signal e power minus t cos of 2 pi t, e power minus t cos of 2 pi t, we can find the value by using either approach. But for signals such as e power minus t cos of log of 2 pi t u of t, the theoretical approach is not viable because we cannot compute the energy by using the integration formula. It does not have a closed form solution. But still, we can use the numerical methods. That is, we can still use the trapezoidal integration to find the energy. So by looking at the graphs, we can also have an intuitive understanding that signal is of finite energy, and then we can looking at the value of energy, we can see it is 0.2208, which is basically a finite value. And we also note that the closed form integral does not exist, so it is not possible to theoretically find the energy. So we can find them by using numerical methods. Thus we can use numerical approach to find the energy of any signal and determine whether it is finite energy or not. Thanks for watching.